this kind of natural fires or the ignition temperatures or auto ignition temperatures. So here previously we did we collected waste from different places, Ahmedabad, Nagpur, like a pan-India thing, east, west, north, south, and then we found out it was surprising to see that there's a waste drive, the temperature rise that is the most prominent, significant was in Bangalore. But then we are not that exposed to frequent fires, maybe because of the climate. But then even in other places, half of this is more than enough to result in frequent fires. So now coming to the subsurface fires, why is this monitoring of CO level important? Because when there is a fire beneath the landfill, it's called a subsurface fire. And how do you characterize or identify a subsurface fire? It is because of the carbon monoxide levels. Why? Because there is not a complete combustion, there is a half combustion, or there is a insufficient oxygen supply in the combustion, because of which there is a CO level increase. And then this can be a parameter to identify the subsurface fires. So usually the concentrations of CO in the landfills where there is a subsurface fire goes up to 500, ranges from 500 to 1500 or even above. And that's quite alarming. So you can see it goes up to 0 to 500 ppm in the locations for 1 hour. Normally when there is a subsurface fire it goes up to 3 times of this in the event of a fire. So these landfills were considered, and then we took some samples and tried to find out what is it. So you can see how is it, what is it. So this is a equipment that will measure the CO for you. It will also measure the CO2, methane as well as oxygen content. So we took this equipment and then we measured it. We also measured temperature, tried to correlate what is happening, and then we saw. So the CO concentrations of 170 ppm were recorded during the pre-monsoon season, which also indicated that there is some smoldering happening at some depth beneath the waste. And then subsurface fires less than 50 ppm were supposed to be safe. Anything more than 50 ppm was supposed to be an indication of the subsurface fire. So concentrations up to 20 ppm were recorded during the post-monsoon season. This is because of the water or the rainfall that water percolates, and mostly it doesn't allow the combustion to happen. Even the half combustion or the insufficient combustion, that doesn't happen because of the concentrations were recorded as 20 ppm during the post-monsoon season, whereas in the pre-monsoon it was as high as 170. Monitoring of CO level in the study area showed that subsurface monitoring events were quite prominent. Coming to the spontaneous fires at the dump sites, spontaneous fires at the surface were more prominent compared to the in the pre-monsoon season compared to the post-monsoon season. Now this is how it is. You can see there is not that much smoldering or ignition happening because this is the post-monsoon season and most of it is saturated, or the moisture content is more than 50% or at least 35%. So this is how the temperature varied with different components of waste. So you can see the fresh waste and the old waste. The old waste had really high temperatures because of the less moisture content. Similar also trend here. So this was a pre-monsoon thing and a post-monsoon thing. So you can see the pre-monsoon thing, the temperatures went up to 60-65 degrees, whereas in the post-monsoon season, the temperatures were limited to around 35 or maximum 48 go beyond 40. So this is a thermal imaging camera where we took the photograph. So if you take a photograph like this, it will identify the hotspots for you, giving the maximum temperature and also the minimum temperature. So once you have the maximum temperature, you can run off the hotspots and then you can maybe decrease the temperature by various means like desaturating leachate or putting water or whatever it is that is suitable to the site. So similarly, landfill surface temperatures can be easily identified using this. So you can see here, this is a pre-monsoon thing. You can see an average of this much, whereas if you take the post-monsoon thing, this is you can see not that much red spots here. So this is the difference. So what it means is that if you have proper moisture content maintained in the landfills, you can avoid these kind of catastrophes or disasters or landfill fires or even high temperatures. So that was the summary here, a maximum surface temperature of cool waste heat during pre-monsoon and post-monsoon seasons where like it was 71 and then the 49 during the post-monsoon season. So this is called thermograph. These graphs are called thermographs, and these graphs were developed using the thermal imaging camera. So what it did is it allowed us to round off the hotspots, that is fire hotspots, identify the smoldering points, and then subsequently extinguish the fire over there. So this thing. So the profiling of surface temperatures was also done using this camera thermographs. So like this. So you can see the red spots during the pre-monsoon season. This is in Nagpur, and this is the post-monsoon season. You can see lots of greens here, you can see lots of reds here. You can see these points which were marked by the thermograph. So this equipment is very good. If you buy the camera, it itself will give you the points where the maximum temperature is existing, and then points where there is a minimum temperature. So accordingly, you can make a plan of extinguishing it or addressing that issue. So here you can see now that high. This is how it is. There is some gas coming out here, coming out from here. So this is how it gets the image. So the temperature within the landfill. So it is an IR based graph. The IR really penetrates into the waste and landfill. It finds the fire spot or temperature spot, and then it records. So the summary of that was what I told. So now one more I have 10 minutes. 10 minutes? I finished up. So there was one more experiment that was conducted within the laboratory in order to find out this heat dissipation that we were talking about, because there is a lot of heat that is generated, and we have to see how it gets dissipated from one point to the other, and then researchers are send us find temperature. So we had a fabricated setup. You can see the setup. This is a steel setup. The inside was glass wool. It was insulated in order to avoid any heat loss, and then similarly this way it was packed. These were holes where temperature probes can be inserted and found out the temperature can be found out. So what happened is this was a setup. There was a plate panel that was there. So when we did it, the different samples collected from different sites. So these were the specific heat values and the thermal conductivity. Conductivity is nothing but it gives the capacity of the waste to conduct heat from one point to the other. Specific heat is the heat generation capacity of the waste at that particular point. So both very important, because the heat that is generated at one point needs to be dissipated or thermally conducted, otherwise it would lead to a fire-like event, like starting from smoldering then to fire. So that is why this experiment was conducted. So these were several readings, correlations between thermal conductivity, moisture content, stability, moisture content, all those things. I'll come to the final graph. So this is how it is. So if you see here, this is temperature. So time in units, and this is the conductivity. So this graph, this blue line indicates the thermal conductivity. It decreases with time, and the specific heat is a green color line. So what happens is that as the temperature increases, the specific heat increases, means that maybe at this point there is this much of heat that is not being dissipated properly because the thermal conductivity is very low, and this results this much of heat that is there, it results in a temperature rise and subsequently a smoldering event or a fire event. So the effective conduction is somewhere here where the conductivity is very high, and then it goes down after this much time period. So that initially what we were discussing, it doubles in quite some time. This is the graph that explains those things. So basically principles like conduction and convection come into picture when you do this, and you need to calculate those things. And this is got published in a very good journal. So this is how it happens. Initially what happens, the MSW that is there, it is fresh with so much content, the temperature is around 25-25. And then here when it slightly starts to smolder, it deforms in shape, giving out the gas or the liquid that is there inside the material, it releases, it gets released, and the temperature increases from 75 to 100, and then subsequently the processes, what happens, it completely gets deformed. This is what happens within the landfill. So in some way that study. So this is one more thing just to see the effect of fire on the leachate, or because whenever there is a fire, people try to put water or leachate, but then during this process, a lot of changes happen. What happens is that in the process of extinguishing the fire, the leachate also brings with it a lot of metals or other chemical contaminants which needed to be studied. So this was a landfill gas potential, with different components, and then how it was experiments were conducted, what was the rise and all those things. So again, same thing here, synthetic waste, fresh waste, all those things. There is a steady rise in the generation of gases irrespective of the kind of waste. So just to give an idea, this much amount of methane per gram of volatile solids was released, that is like around 31 liters of methane per gram of volatile solids was released. So you can imagine how much of gas will be released when there is a 1 kg of waste that gets burnt, and subsequently this much, almost 40 kg of or liters of CO2 was released. Just to give an idea. This is the experiment how it was conducted. We had a box fabricated, we had waste in that, we deliberately put fire in that, we started recirculating leachate. This is also done to see how much of water does it take really to extinguish the waste. Like say this was 1 meter cube of waste, and how much water does it really require to extinguish the waste. So if you see 500 ml of leachate quantity was used for each circulation, and then the leachate circulation was carried out after 3, 8, 16, 24 hours. So after 30 minutes of each circulation, the leachate was collected and their properties were checked. So if you see that the leachate was analyzed before ignition, this was the parameters, and after ignition, after 24 hours, these were the parameters. But then immediately if you see there is a huge increase in the parameters. Gradually there is more or less, there is not that significant increase in the KDAs and other things. But then what is more important than that is the COD and BOD do increase. Because if this water or this leachate is let into some fresh water or some lake water or something, it really damages the quality of water. The metals that are present there, it was like, this was like quite interesting, because some of the metals concentration increased after 24 hours. If you see arsenic increased, this also increased. Some do decrease, but then that was not that significant, because arsenic is one of the very cancerous components. So at the end of the day, what we saw is like estimate showed that the quantity of leachate that is required for extinguishing 1 meter cube of waste is around 48 liters. That is quite astonishing. It was around 50 liters for 1 meter cube of waste. So imagine when there is a landfill fire, how much of water is required. So when that much of water is poured into the landfill, it cannot go anywhere because there is no proper leachate recirculation system or collection system. And obviously what happens is a disaster, because it brings down the waste along with it, and whatever the sediments are there, it just falls on that. So this is the thing. And what is needed is a integrated approach, a proper engineering system, a system for waste composition detection, early surface landfill fire detection system, and then there is a subsurface fire detection system. So CO can be one of the parameters, and if there is any increase in CO, we can immediately put some water over there in order to decrease the moisture content. And then the system for extinguishment of surface fire, if there is any, then because the fires are classified as class A, class B, and all those things. So sometimes the artificial things like surfactants also can come into the picture, which is quite good in extinguishing fires. Then system for extinguishment of subsurface fires, this also needs to be put into context, which is mostly missing in 90% of the landfills at present. Then controlling measures to avoid the landfill fires. It's like several measures are there. One is like the most important being keeping the moisture content between this, so that it doesn't go below 5 and it also doesn't go beyond 25. Because if it goes beyond 25, there is a structural instability which actually collapses. And if there is a moisture content less than 5, it leads to fires. So with this I conclude. Thank you very much for patiently listening. Thank you.
Excuse me, sir. I had a doubt.
Please,
In table,
it's open to questions.
yes, sir. In table, you said that heavy metals are increased after.
Yeah, so not all the heavy metals increase. Very few, arsenic, there was a quite increase.
Okay.
So there was like in some percentage, if you take in large quantities, there was some increase in the arsenic.
Why it is so, sir?
That might be because of the waste component, because there is nowhere the arsenic is coming from. So when you put water, the water might also have arsenic, because nowadays what happens is like tap water also contains arsenic, the groundwater also contains arsenic. So the geogenic contaminants that are there, that is like naturally present in the water. Some places iron minerals are there, some places arsenic is there. So those kind of waters, what we missed out here is that we didn't measure the quality of water before separating the water. So that is the only source where from where the metals or other things could have come into the system. Because we measure the properties of waste before putting into the box or the experimental box, but then we didn't we somehow forgot to measure the quality of the water. So that might be one of the
Sir, other than India, which are the other countries face this issue?
mostly all the developing countries are facing this issues because they're not having a properly engineered landfill. Like I said in the beginning of the lecture, if you see the West and the US, they have their own ways of dealing with it. They are not that much critical with respect to this. But then if you take the developing countries, these kind of incidences are more common.
What is the latest What is the latest technology you are using to control these type of incidents?
Control?
Incidents, that is.
So actually, if you ask me, what we are doing is we have suggested simple measures. Like the period where the temperature really goes up is the summer period, that is between February and June. So during this time, every week monitoring at the surface or at the landfill is required, along with CO monitoring for the subsurface. And if there is any increase in temperature, what we recommend is once in 2 weeks, no need to recirculate the water, but then recirculate the leachate just to see that the moisture content doesn't go below 5%, so that these kind of events can be avoided. And second thing is we have suggested some watering systems. There will be poles with sensors, wherein it will automatically send a signal if the CO concentration is more than 20 ppm, CO2 concentration is more than 500 ppm. So there will be a data center at the office that is just beside the landfill. If there is any of such kind of thing, there will be an alarm, and then because of that alarm, there will be a action taken, that is washing the waste. There is no if you ask me, there is no technology, advanced technology as such to resolve this issue. I think with simple common sense and simple practices it can be resolved. Only thing is it has grown up to this extent. This is not that an issue if you manage it properly.
Hello sir, in New York City, the converted the shutdown landfill into park.
Sorry, I didn't get your pardon.
Yeah, in New York City,
Yeah.
the shutdown landfill sites they have converted into park and
Yes.
So can we adopt this technology in India?
Madam, for your information, that is not a technology. What they do is they completely compact the waste. They see to it that that waste site doesn't have any potential to damage any of the things that come up on the surface. Say for example a building or a park or whatever it is, and only then they go up for certain things. But then in India, what happens is that they don't do that kind of test. Say for example, there was a recent construction. I don't know the place in India. There was a construction on the dump site. They constructed some building, office, and then after a period of time, they were this thing caught fire. The pipes and the wires were really rusted and corroded. When they investigated the issue, the forensic team told that there is a landfill or there is a waste dump beneath which is releasing H2S, that is a corrosive gas that is corroding or damaging the parts. So what has to be done is a thorough checkup has to be done. We have to see whether the waste beneath whatever is there doesn't have any potential of releasing any gases, and then we can go for these kind of things.